Today, the 16th edition of the Vision Summit was off to a flying start. Key officials from the Government of India, as well as many key states across the country, presented to us their initiatives in ESDM. This was followed by keynotes from Mr. Imran Erez of Tower Semiconductor in Israel, as well as Dr. Ashwini Agarwal of Applied Materials. They ended with an exhilarating talk on ethics in AI by Ms. Priya Cherubu of Intel Corp, USA. And this was a unique event of the summit. So today's curtain raiser, we are going to focus on manufacturing, startups, and MSME. And we will have this kicked off with a panel discussion on semiconductor manufacturing supply chain, the opportunities for India. This session will be led and moderated by Mr. Rajiv Kushum, who is the chairman of iesa. I would like to welcome the panel at this point and ask them to take over.
Welcome to the first panel of iesa Vision Summit 2021. As you all know, this is the 16th edition of Vision Summit. So we're already 16-year-old, and we have come a long way in terms of the quality and the kind of speakers and the kind of sessions we are having this time. And this session, which is pretty unique, is, as you know, one of the goals of iesa is to increase India's influence and footprint into the global semiconductor supply chain. We wish to propose, and that's the goal of this panel, is to propose a strategy for developing India as a critical player with focus on following three important segments in the semiconductor manufacturing supply chain. Is equipments and components needed for semiconductor manufacturing fabs, materials, which is minerals, chemicals, and gases, services and skills required for fab and ATMP. As you all know, semiconductors has been growing at a phenomenal speed in the last couple of years. I think this year, the estimates say we will cross $525 billion, which is almost 20% more than what the semiconductors did last year. And as a result, what we are seeing in next couple of years, 3 years, the projection is that semiconductors will reach $700 billion. And as a result of this, you would have seen there have been announcement of 27, in fact 28 fabs in last 12 to 16 months. And as a result of these, it is very important that we see the overall ecosystem, how it looks like. I think when it comes to the semiconductor manufacturing supply chain, this whole market is today at $180 to $200 billion. And this is supposed to grow at a CAGR of 10% for the next decade. And now in this, equipment comprises roughly around $75 billion, and materials is roughly around $52 billion, and services $60 to $70 billion. If you see, is almost 30% each. And we have today two eminent speakers from Lam and from Applied Materials, who together basically have a sizable portion of equipments and services. So I'm happy that we have a great panel here, which comprises of industry veterans and then subject matter specialists, and from academia and government as well. So I'll do a small introduction, which is of the panelist. Mr. Srinivasan is Managing Director at Lam Research, which is US-based global supplier of wafer fabrication equipment and related services to semiconductor industry. He has been with Lam for 5+ years And before that, he worked for Novellus Systems for over 15 years. We have Vikas Dabir, is Senior Director India Site Operations with Applied Materials and has held leadership positions in multiple organizations, including Texas Instruments. I realized while seeing his LinkedIn that there was a brief period where we worked together in TI. So I completed 15 years in TI this month. And he has worked in different companies, including TI, Advent Solar, and Applied Material Inc. is an American corporation that supplies services and software for materials of semiconductors. And we have Professor Raghavan. I think his resume is very, very strong. I think he is the subject matter specialist in semiconductor materials. I think he has a doctorate in materials engineering, and he has a post-graduation from Indian Institute of Science in metallurgy. I think his achievement list, if I keep on speaking, I think we will finish the panel and we still may not be able to do justice to it. So I stop here and we will listen more from the panelists. And last but not the least, we have Sagar is from Invest India, which is basically Government of India 50-50. It is 50-49, 51-49. 51 is private and 49 is government investment. And he plays an important role, acting as a bridge between industry and government. And he actually helps both the government as well as industry. So he kind of mediates between the two important pillars of any economy, which is government and industry. So we'll start with questions. I will start with Srinivasan. So I have a few questions. So we'll go around the table. I'll start with him. So my first question to Srinivasan is, how do you foresee the growth of global manufacturing supply chain over the next 10 years from a semiconductor manufacturing equipments, materials, which includes minerals, chemicals, gases, and services? And what are the key drivers?
Yeah, thank you very much for having us on this panel, Rajiv. It's a pleasure and an honor to be associated with this eminent panel here. Before I kind of get to that, I would actually like to also add one piece of input here. That is that in addition to the equipment, materials, and services legs that you've talked about, I think it's important that we also talk about IP as an other important leg, because in our industry, manufacturing and R&D are very intricately interconnected, and you cannot actually kind of separate out manufacturing or services or materials from creation of IP. And so that, with that having been established, I will directly answer the question. Our industry is driven primarily by technology inflections. When I talk about our industry, I'm talking about the equipment perspective. We are driven by technology inflections at our customers. The customers obviously being people who manufacture devices. As we look forward, there are a number of very exciting inflections that are taking place or are slated to take place in the next decade. We are already in the midst of this heavy boom in 3D NAND memory. EUV lithography is beginning to have a huge impact in our industry. Many people are beginning to transition to novel gate architectures, including gate-all-around FETs. 3D packaging of microprocessors and other devices is also beginning to be a significant innovation that's going to take place over the next 10 or so years. And companies like ours are focusing our equipment and process innovation in a way that allows us to drive the future in these device manufacturing. And these innovations could include a variety of different things, including new materials, new process technologies, new ways to execute existing processes more efficiently, also leveraging our big data architecture, artificial intelligence, machine learning, and putting to use all of these things to manage defects and productivity at our customers is probably the most important attribute that I see going forward in the next, say, 10 years or so.
See, the Follow-up question I have is, how do you see India's capability in terms of participating in the global manufacturing supply chain needs? And what are the areas where India can have a play from a current state of affairs versus what could India do to achieve higher share in the near future and its journey over next 10 years?
I would take a holistic approach to this, and that's why I actually asked for IP to also be included as part of this current three-legged stool that you're talking about. Put IP in there. So looking at it holistically, right,
Okay.
as we look forward in the industry, it's probably important to have a conversation about meeting the needs of the future and not try to merely replace what exists today. Because, and of course, both of them will probably be important. You have to establish yourself using existing processing methods, existing materials, and so on and so forth. But I think there's got to be a significant element of what's in the future also. Because in our industry, overcoming the power of incumbency, in other words, substituting for another supplier, can tend to be very difficult. And therefore, I think some element of it should look forward. I think another element, and as the government is proceeding with its effort to bring a manufacturing facility, a fab in India, we should look at it holistically. The equipment, materials, and services industries will benefit enormously if there is a customer, a local customer in India, a fab in India, because the cycles of learning, the cycles of innovation get massively accelerated when you work in close collaboration with your customers. And so I think from an India perspective, we are already doing wonderfully well on IP creation. Companies like Lam and Applied Materials have very large fractions of our R&D workforces located in India today. So from an IP perspective, we're very well situated. From a services perspective also, we're actually very well situated. Companies like Lam use Indian talent to provide global installation and maintenance support for our equipment across our global customer base. And so there is a lot of talent and a lot of domain knowledge in that particular area that we can already build on. Obviously, the equipment and materials part of this is still new, and that needs to be incubated.
Thanks, Vinod. So we move to Vikas. Vikas, a couple of questions for you. What are the key semiconductor manufacturing equipments that account for 70 to 80% of the total requirement for a fab? And follow-up question on that is, what are the important elements of the equipment, whether it's components, spares, and software?
First, thanks for inviting me to be on this panel, Rajiv. And as we discussed, glad to know we were alumni at TI. Professor Raghavendra, nice to see you after a long time. And from Invest India, we just met a couple of weeks ago. So great panel and great topic. I'll give a slightly different take than what we heard from Srinivasan, right? So I'll give a more operations view. And before we go there, right, let me just add on to what Rajiv said. TSMC just announced another fab with in Japan worth $7 billion. So you can, and that's very, very focused on specialty, what we call as ICAPS within Applied Materials. These are all specialty nodes. So the market is growing, and the way you should think about the market is now it is the significant change in the use of semiconductors. The content of silicon has just exploded, even without a lot of the industrialization going to 5G. Automotive is one of the great examples. The cars, the first car I had, the Maruti 800, the electronic content in that compared to the XUV that I drive now, massive difference in the electronics. And this is so across. Plus the drivers for electronics over the last 18 months because of the pandemic. Everybody has had to increase the amount of communication equipment at home, laptops. I myself had to get another docking station and monitor to work from home. So things like this has just increased. Then coming to the real question, right? So if you look at the real equipment, semiconductor, if you all go back to our high school physics, making of semiconductors is actually putting material and etching it to make the circuit. So there's plenty of deposition and plenty of etching. And there are lots and lots of different processes in that. Professor Raghavan can actually, like you mentioned, Rajiv can take lectures on that. So if you look at the way the market is or where it is characterized, the fab equipment is, like you said, around 75, and this year maybe around $90 billion. The back end stuff is another $20 billion. So that's how the differentiation is between the wafer fab equipment and the packaging equipment, as we call it, that really finally puts the ICs that go into the PCB assemblies and ends up in our mobile phones and stuff like that. So that's how I would characterize it in terms of market segmentation or where the types of equipment go in. I hope that answers your question, Rajiv.
Thanks. So, what are the elements of the equipment?
Rajiv, or
I
what?
think that's one. Are you able to hear me?
Yeah.
Your voice cut out for a moment and I can't see your video.
Is it? Okay.
Yeah, we can hear you, Rajiv, but we can't see you.
Okay. Okay. So I don't know. Is it probably my Wi-Fi is not stable here? That could be the reason. So, the office, I don't know. Sorry. Yeah. Should I stop the video and then start it again and then see?
We can see it now.
Are you able to see?
No, it's fine, Rajiv.
Ah, okay. Okay. So thanks, Vikas. So I think the follow-up question was, what are the important elements of the equipment, the fabrication equipment, in terms of components, spares, and software, and how big are those individually?
Let me just touch base on that, right? If you look at the equipment that goes to make the wafers, there's a lot of chemistry involved in the processing. So that's one piece of it. But there's a lot of mechanical and electrical parts that go into making the equipment. Aluminum. Semiconductor equipment is one of the largest aluminum consumers in the world. Control systems, software to run the equipment, it's all pervasive. And both Lam and Applied, like he mentioned, the talent for doing all this engineering work, the R&D work, writing the software, controlling how the tool performs, collecting the data, analyzing the data, making improvements, helping our customers improve their yields from using our equipment is all very interconnected now. A lot of it requires very, very strong mechanical engineering knowledge, very, very strong electrical engineering knowledge from the control systems, and the actual material science and chemistry knowledge to actually make the wafers the way we want it. So that's how I would divide it, with, of course, software element being a part of it. Servicing, I think already we heard from Lam. So that's a big part of the process. There's also a big portion of the spares. There are a lot of spares are not only breakdown spares in the semiconductor equipment, because you can't take contamination. You've got to take the parts out, clean them, re-put it. So that's all a part of the service agreements that we do for our customers. There's a lot of spares that get rotated in and out. There's a lot of course, breakdown that needs to be replaced. So spares is also a very big part of the business. Especially your equipment runs for 20 years. It doesn't go away in 2 years. Your technology keeps increasing, you add new technologies, but these equipment go for the older technologies for the other pieces of the semiconductor industry. So it's not like the equipment gets thrown away. So the spares over a period of time become a big part of the business.
Thanks, Vikas. Thanks. So I move to now Professor Raghavan. Straight away to the question. Since you have a great background in materials, how is academia geared up to produce experts in material science? Do you see interest in Indian students to pursue career in material science and chemical engineering?
Okay, thank you, Rajiv. And again, it's a pleasure to be on this panel, having people like Vikas, Srini, Sagar, and yourself, of course. And one of the things that I tell my students, this is given you introduction in the beginning. One of the things I tell my students is that they're ready to graduate on the day, not just because they are aware of what they did for their PhD, but on that day, they should also be aware of what they don't know about. And that's very key. And given how diverse this materials requirement of the semiconductor industry is not just that it's big, it's extremely diverse. And I think Vikas and Srini, who are the users of these materials, would probably be, better or bigger experts than I am at it. For the simple reason that, just yesterday after I talked to you, I was looking at some numbers, and there are a few hundred solids, liquids, and gases, if I can put it that way. Therefore, it's very difficult for one person to be an expert in all of this. I would be fibbing if I told you that. And if you take India as a country, then you would need people who have a background in metallurgy or material science. And that's how world over, the field of material science and engineering as we know it has emerged. It was first metallurgy, and then it became material science and engineering. And then, of course, people who work on ceramics and polymers. But then you also need the chemists, people who work in basic chemistry. And then you also need the chemical engineers. So the quick answer to your question as to whether there is an interest in becoming part of, let's say, an industry, or let's say even an academic organization in like sense, which does not cater to what is traditionally taught in many of our standard engineering colleges even. Is there an interest? The answer to that is yes, there is an interest. But there is also a certain anxiety associated with it. So if you, for example, go to, when we interview students who come to us to do our PhDs, do their PhDs here, people from the traditional electrical, mechanical, metallurgical, or chemical engineering backgrounds, at the end of the day, what we teach them is slightly different from what is taught in most of the current core disciplines. So there is an anxiety level, but we do overcome that. So, we talk to them, we have internships, we have various functions we organize to tell them that what they learn can easily be mapped onto something that is required by the semiconductor device industry. And once they overcome that anxiety, then I have seen students perform really well. So the answer to your question is, given that this is also a talk about supply chain, is there a supply of students or trained manpower from India that can cater to that industry? The answer to that is an emphatic yes. And you know that in Silicon Valley, ICs don't just stand for integrated circuits, they stand for Indians and Chinese too. And the second question as to whether there's interest amongst Indian students to cater to, move on to working in this field, the answer to that also is a yes. And when things like this fab, etc., come to India, and it becomes more, part of the mainstream news and knowledge, I think people will come more readily to these industries.
And I think we as the association, I think we'd definitely like to work with you how to make it more popular and lucrative for people. I think there may be a lot of mindset, which is their mindset change will be required. People need to know beyond the traditional branches. I think we as industry have to actually work on that. The follow-up question on that, Professor Raghavan, is what are the standards or the quality parameters required for materials to be qualified for sourcing?
I see. So I think there was, one more question in terms of what are the materials that are required. But so if you take the semiconductor industry, I think as Vikas and Srini also have told you that you have the bulk and the specialty materials, right? And if you ask the question, what is it that India should concentrate on? That's not an easy question to answer. Do we have the capacity to make materials in bulk? We do. I mean, we do that in various other sectors. in the pharma sector, I think we are one of the global powerhouses for making generics and so on and so forth. So do we have the ability to set up that infrastructure and make it? The answer to that is yes. But if you ask me this question, would you set it up anew? I mean, would you reinvent the wheel? I would be a little careful because the semiconductor industry runs on trust, and once they, I think, establish a supply chain with one supplier whom they qualified, based on whom their fab works very well, they are not going to change that supply of even something as trivial as sulfuric acid so easily, right? So the best thing, in my opinion, there would be to then get some established player world over who needs to build capacity in India, and allow them to invest here and do the mass manufacturing here, if I may, to cater to that supply chain. And in doing that, you will be competing with the rest of the world, right? One of the things that Srini said that caught my attention was it would be good to have a local fab in India to cater to such an industry if it comes up. On the one hand, it is good, and I'll tell you why. To answer the question you asked me to begin with, from which I'm digressing. But on the other hand, if you look at the global supply chain, you will see that a big chunk of the suppliers are not necessarily, even if you take Asia and Korea and Taiwan, they are from all over the world. So that is the good piece of news for India, that you don't necessarily have to have the fab to establish such a supply chain. But given that it's already established, I agree with Srini that it might be more difficult to get into that right now. So what is the biggest key? It's not just about making it in large quantities, but also to cater to a quality, a quality that somebody will trust, and one that can be qualified in a fab. And so to answer your question, do we have the ability in India right now to measure quality? It has to be set up. I think, for example, if we take things like SIMS and atomic emission spectroscopy, which are standard tools for measuring ppb levels in these chemicals, it's not as easily available in India, but they need to be set up. And once they are set up, then standards are available. So one can look at the quality levels in these materials in India internally as well. But one thing that India could work on and also look into the future, I believe Srini was talking about various new things that are coming up, like extreme UV lithography, novel gate architectures or materials for those, and also packaging. So one could look into developing materials for these specialty applications too, instead of just concentrating on the bulk bit. And I know, for instance, I think there was a program in IIT Mandi where they had made extreme UV or deep UV lithography resists one of those two. So stuff like that is possible, and it can come out from India, and it can result in generation of IP, like Srini pointed out.
Thanks, Professor Raghavan. Thank you very much. So I move to Sagar.
Rajiv, before that, can I just make one quick comment?
Please.
Vasu, to your point, right? I just want to add one thing. Can the talent definitely exist in India? But I'll add to the talent, the people who want to set this up should remember three things. And I say this every time. Getting into semiconductor industry requires patience. You cannot get a revenue for 2 years. It takes that long to get qualified. If you don't have the patience, don't enter into it. Second thing is you need to show value. You have to show value. This is a well-established industry with a lot of established players. So you need to remember to show the value. And the third important thing I would add there is you need to remember to invest, because the standards for semiconductor industry are very different from, let's say, pharma or something else. So mentally you should be prepared that, although let's take a simple process like cleaning. What cleaning you may be doing for aerospace will not work for semiconductors. You have to have a mental attitude that I will invest in special semiconductor lines to make it work. So these three things I would just like to point out to the audience.
Thanks, Vikas. Thanks. So moving to Sagar, see a couple of questions. Are there policies in place which could encourage the firms in India to look forward to this opportunity? I think we address what Vikas made a point and Professor Raghavan also made a point. What are your suggestions which would help accelerate India to achieve growth and gain a better share in the global semiconductor manufacturing supply chain? So
Thanks, Rajiv, for inviting me to this panel amongst this, very eminent and experienced panel. I think I'm the least experienced, but I will sort of share my, learning till now in this sector, and I've been working to enable a sustainable semiconductor ecosystem in the country. So I will take your second bit first, Rajiv. When you mentioned about the share in the global supply chain. So, as we all know that, this global semiconductor supply chain is distributed, it is diverse, it is networked. And, I also see it as a very beautiful example of the global cooperation, where based on the geographical specialization, many countries work to deliver a single chip, if I can refer one study which says that, that a particular chip passes more than 70 borders, 70 times passes international border before reaching the end customer. And there is a joke that it's not rocket science, it's much more difficult, and it is vulnerable as well. So, though it shows the spirit of cooperation, but it is also vulnerable in terms of geographical concentration, in terms of geopolitical frictions, in terms of availability of talent and R&D funds. If imagine if a COVID-like pandemic has happened to a different place, started from a different place, then it could have impacted. It already has impacted, but the repercussions can be much more severe. So, and we though it's an example of global cooperation, but we have to understand this debate between realism and the idealism, that we need to diversify the facilities, we need to have the facilities, and we need to bring this entire ecosystem in the country. And if you see the kind of policies, because these, if you see in the last couple of years, our ease of doing business rankings has improved. If you see the domestic production of electronic items, you'll see that it has grown from USD 29 billion in 2014-15 to USD 76 billion in 1920, with a CAGR of around 23%. And India's share in the global electronic production has also increased from 1.2% in 2012 to 3.6% in 2019. So these are the some green shoots in the bigger scheme of things. And also, if you see, because of the policy, if you see the most of the global design houses, have their largest design centers in India outside their home countries. So yeah, there are some policies which are playing their roles, and because of which our country is getting benefited. When it comes to manufacturing, there are policies like PLIs. If you see, the kind of the bouquet of these PLI schemes, PLI large scale electronics, PLI in IT hardwares, and then the specs scheme, which is for promoting the electronics and semiconductor manufacturing, and the EMC scheme. Together, the PLIs for both IT hardware and large scale electronics, specs and EMC are around 7.5 billion USD, which is a very good amount, and it is adding a lot of value to the electronic production. If you see in the recent year, the kind of mobile phone production which we are amongst the top countries in the world in terms of finished mobile phones. Similarly, if you see recently, there are schemes or the expression of interest when it, particularly for the semiconductor fabs, be it in the compound category, be it in the silicon CMOS, or in the display fab categories. So yes, Rajiv, the schemes are coming up, and I'm very hopeful that with the kind of leadership, the support which we are getting from the highest leadership, and these particular schemes, and probably schemes in the semiconductor manufacturing, we can sort of have a sustainable semiconductor ecosystem in the country. Yeah.
Thanks,
Thanks.
Sagar. A follow-up question on that. See, I was talking to SCL, which you introduced to me in Dr. Jaspreet. See, what I understand that some of the domestic fabs, which I'm talking about SCL, have started buying materials from the local industry. What stops them to start exporting to the fabs around the globe?
So yes,
maybe anybody else can also
Rajiv,
speak in. Yeah, so I will start with you, and this question is open to everybody. So yeah, I was made to understand close to 15% of the chemicals they have localized. That is the case. What's the globally. Apart from what Vikas talked about.
So I lost you in between, Rajiv, but I think.
Yeah.
I lost you in between, I think, but I got your broad question that, that how, what is the current ecosystem and why, the export, why they are not exporting it. So as far as my understanding is concerned, Rajiv, when it comes to the semiconductor grade chemicals and gases, there is a issue because of the natural reason. Am I the only one who is hearing Rajiv's
No,
voice?
Rajiv, your voice again broke up. It's the same problem, Sagar. All of us had a problem.
Okay. So am I audible clearly, Vikas?
Yeah, I can hear you.
Okay. So yeah, Rajiv. So what my understanding says is that though we have a very vibrant chemical and gases ecosystem, we have a very a vibrant pharma industry, but when it comes to the semiconductor grade chemicals, semiconductor grade ESGs or the bulk gases, so there is an issue there, and we need to develop those capacities because, to the best of my understanding, most of the gases and the chemicals which unlimited fabrication facilities we have in our country, they are, I think, importing, and especially if it comes to the CMOS grade fabrication facilities, Rajiv, then it becomes even more difficult because you need even more specialized gases, and the specs are more stringent there. But yeah, for the maybe the after CMOS processes or backend processes, we have some chemicals and gases for that kind of system. But for CMOS, to the best of my understanding, the availability is not there. Yeah.
So anybody else would like
Rajiv,
to?
can I just make a comment? Yeah, Rajiv, I would like to comment.
Oh, sorry. Go ahead.
Yeah, go ahead.
So Rajiv, I think, and this is based on our discussion that we had around a month ago, right? If there are these companies that are already qualified at SCL, I'm understanding that is semiconductor complex, then we should get in touch with those suppliers and we can actually land. And a lot of companies here applied. I'm telling you, I'm very willing to put my engineers to work with them if they are willing for the 3 parameters I said. If they have the patience, they are ready to invest, and they are going to show value. But Rajiv, if you remember what you and I spoke about a month ago, this is really, we should get these companies and we can really help them succeed in the global market.
So just to add here, because
also,
yeah, please, yeah, sorry.
Yeah, I'm sorry. Just to add to that, I think Professor Vasu also mentioned the customer, the fabs themselves have these very trusted relationships with these suppliers. The overcoming the power of incumbency in this industry is very, very difficult. And so a lot of it is a trust aspect that even Vikas has talked about. I think we have a better opportunity in terms of materials.
Go ahead,
Sorry,
Sagar.
please continue.
No, I was just going to say that I completely second what Srini said, and that's what I think I had alluded to in the beginning. But I was about to say that now that we have Applied and Lam, 2 of the biggest companies in the world, who develop processes for the semiconductor industry. Of course, the processes then get established in the fab on the tools they supply to them. It might not be such a bad thought. I think this is what Vikas mentioned, that if there's somebody supplying, chemicals to SCL. To begin with, one can even probably touch base with Applied or Lam to see if the chemicals they supply there can qualify in an Applied or Lam process, for instance. And then it will be an uphill task. There is no doubt about it. See if some fab outside of India is interested. Of course, it has to be both tonnage, quality, and then qualified. All three have to be there. This is where I think Srini's thought that if a fab comes in India, because shipping is a big thing. If you have to ship a tanker load of sulfuric acid, it's easier if you can ship it to somebody across the road. So if you have a fab in India, these things will accelerate a lot more. I'm guessing acids get shipped in the tanker load. Maybe Srini or Vikas could add to it, but it's not that easy, I think.
Those are bulk chemicals. Yeah, those are bulk chemicals. And I think to your point, Professor Vasu, I think the right way to start is to look at things that are actually a little simpler and a little bit more commoditized. And maybe it's the chemicals that you use to clean wafers, and that might be a good place to start. Rather than going for some very sophisticated precursor chemicals for depositing thin films, for example.
So Rajiv, if I may add here a point, so based on my experience and my visit to SCL, my understanding is that for the CMOS facility which they have, so they use I think most of the chemicals and gases are sort of imported, and after the CMOS process in their MEMS facility, so for that they have some local suppliers, and acids is not a problem. The main problem is with the gases. Nitrogen they generate in-house, they have a plant, and so major problem is with the specialty gases and the chemicals which they face. Yeah.
Thanks.
Just add.
So I come back.
Just add the same thing that everybody said, right? But build an ecosystem. I think we have the companies here. If there is a local company that is willing to go after the three things I mentioned, we have partners like Applied, Lam, TI, and other companies who will spend time, give them the technical support needed for them to succeed. But they need to have the patience and they need to be ready to invest. Thinking that what I do for pharma will work here is not going to cut it. That mentality, if they don't change, it's not going to work. And we can offer our technical help to them to get them qualified, tell them what is needed, but they need to come with a new mindset.
If I can quickly add one bit, Rajiv, see, I think Srini or Vikas told us that, or you told us that 28 new fabs are being established in the world. The question then one needs to quickly look into if down the supply chain, if there is enough capacity to keep those fabs running, and wherever there is a gap, see if you can talk to one of these big suppliers and say, hey, look, I'll give you the required infrastructure. You come and set up your specialty gas or chemical facility here, and move quickly right now. I think we have an opportunity to do that.
Yeah. Say I come back to Srini. So what are the current and likely technology changes which will have an impact on the type of equipments to be used in semiconductor manufacturing?
Well, I think we talked about that in the initial part of this conversation. I think there's a lot of inflections, technological inflections going on in the semiconductor manufacturing flow right now. I mean, our customers are beginning to implement all sorts of new gate architectures. We've spoken about that. They're implementing extreme UV lithography across a wider range of layers. And so the ability to improve yield and performance of extreme UV lithography equipment, the development of new resist chemicals, as Professor Vasu mentioned, those are also very important inflections, technological inflections taking place inside the industry. We've got the growth of 3D NAND. People are talking about 256 layer. God knows after that it becomes 364 or 512, whatever the number is. There is just a lot of growth in those kinds of areas. New memory is also a very interesting application where the ability to both deposit and etch new kinds of materials will become very important. One of the very interesting things about our industry is 20 years ago, if we looked at our industry and looked at the periodic table of elements, you would see that a very small fraction of the periodic chart was actually employed within the semiconductor industry. Today, it's actually much wider. All sorts of metals and other elements are beginning to be used in semiconductor devices. And so therein also lies the opportunity, right? Because therein also is the probability that there is no incumbent and that there is an opportunity to be had to harness our existing strengths in the technical fields. Or the pharma industry has grown up here. And so leverage those kinds of strengths, keeping in mind all of the things that Vikas talked about, the trust, the commitment, the ability to invest. You have to have cash commitment, no doubt about that. But keeping in mind all those things, there are the new opportunities that are being driven by the technological inflections taking place inside the semiconductor industry, some of which we just mentioned.
The follow-up question would be, how can the academia industry, I think this is open to everybody, I think anybody can. So how can the academia industry, government work together to set up a winning value proposition for India to be amongst the valuable contribution to the global manufacturing supply chain over the next 10 years, hence be able to achieve a sizable share of the global market? We can start with you, Srini, and then probably others can also come in.
I'll give a very short answer. But we pride ourselves in the industry on having a very collaborative mindset. And the same would be true for Applied Materials, for all of our customers. So we believe very strongly in being collaborative. If you go look at a chart of universities with which LAM is actually associated, it runs into 2 PowerPoint pages in font 10 size. That's how many universities we engage with, and we included amongst which is the Indian Institute of Sciences, represented by Professor Vasu. So it's very important that the government incentivize not only universities and colleges like the Indian Institute of Sciences, but also their national lab system should be opened to a collaboration with industry and with academia, so that there is this sharing of knowledge that takes place. We're able to leverage and commercialize very quickly things that are developed inside our national lab and university system. Today, there's a lot of work that goes on inside these world-class institutions that never makes it out, unfortunately, into the commercial realm. And so something has to change there. And I'll probably defer to Professor Vasu on most of the rest of it, because he's probably got a better experience of how academia works than I do.
Vikas, you want to go?
I can just put a number. He said 2 PowerPoint pages, font 10. I'll tell you, we work with 84 universities, and this was before coronavirus. So in the last 18 months, we have probably increased. So we are extremely collaborative. And I'm going to go on my soapbox here for a moment. The one thing that I think that I've been talking to several people on this, the government should look at putting a real 300 R&D setup, just like IMEC, where design houses can go and get their tape outs done. That will go a long way for not only companies like Applied, but the whole ecosystem. I think that is something that, and today India has the money for it. India has the money, it has the talent. We just need to get them act together to put this there. The characterization is very expensive, as you all know. Professor Vasu, you are most aware of that. So if there are common facilities that the government can put where the design houses do the tape outs here in India, that will go a long way, is my firm belief. Back to you.
Right. So, Rajiv, can I respond to that?
Please.
Okay. So I'll just take off from where Srini left, and I think both LAM and Applied, and I can attest to that, work very closely with the Center for Nanoscience and Engineering, and therefore the interest is there from both sides to collaborate, both with LAM, Applied Materials, and other industries who are there in India, as it is elsewhere. Where I see is that the problems that industries come to us with, I put them in 2 buckets. One where a problem needs to be solved for something that has to go to the market within the next few quarters, right? So that kind of thing, academia is typically not very good at. Okay, and that kind of thing is where, like Vikas pointed out, if you like a Catholic University IMEC kind of system or ecosystem can be set up. So where somebody comes in, they are getting trained, but across the road there is an IMEC and they know what is to be done and how the road will eventually lead to a larger, employment in a fab or so on and so forth. So once that ecosystem is set up, that is where the short-term problems that can be given to, let's say, a BTech or a master's level project student if required, and things can be pushed forward. That's where it will work. But to work with students who do their PhDs and so on, it's better to work with them on slightly longer term problems. And this is where it is very key to be patient, where everybody who comes on board, and thank you, Vikas, patience is a key word in this industry. And if you see documents from some of the countries that have embarked on this process, for example, I know GAN, I know there's a question you'll come to. If you look at programs on GAN, you will see documents back in 2000 which talk about a 2025 vision and how you have to step through it. So one needs to fix these 5-year, 10-year goals and then work with industry, work with academia, let's say even the PhD students. And there are now protocols available for IP sharing, ownership, and so on and so forth. So that can very eminently be done. And I say this because I happen to be chair of the IP cell in ISC as well. I stepped down in 2020. So those protocols are available as well. And we have MOUs with both Applied and LAM that take care of IP.
Thanks, Professor Raghavan. So I have
I also want to add
question.
A bit to this. If you may
Go
please
ahead.
allow me to add. So basically, I feel that the trinity of government, industry, and academia is a key enabler to to a sustainable semiconductor ecosystem in the country. The global semiconductor market will be like USD 1.2 trillion by 2030. With a CAGR of 10.34, it is growing. And I would here at this point, if we want to really capture a significant share there, I want to sort of, just highlight a model, which is the Special Manpower Development Program, which is a very, very beautiful example that how industry, government, and academia are collaborating. We have, I think, more than 150 chips fabricated, including 120 in SCL. So if we can have similar models and the kind of talent, I think there is no other country in the world right now which is, so beautifully placed to lead in that sense, because if you see our median age is around 28.1 years as compared to Taiwan, which is 40, Japan 47, China around 38, US 38, Australia 37. We are already doing some very good programs. MHRD is running the Spark, the Gyan, and Gyan Plus. If somehow we can align these programs for the semiconductor manufacturing and design. I understand that CEN and SENS at ISC and IIT Bombay, they are doing some really fantastic stuff, but then we need to comprehensively align the effort in a very coherent way. So I believe that we need to develop a win-win ground together for all of us to enable and to actually leverage better academia, industry, and government. Yeah, thanks.
Thanks, Sagar. See, one last question before we probably may run out of the time is that what is the likely road ahead for India for the long term or maybe even for the short term in this space? And I may go to probably Vikas, followed by Lam, and anybody can chime in.
Well, it's all in our hands. Yeah, Rajiv, and again, I go back to our discussion a month ago or so. I think the time is right every time. The time was right in 1999 when we first started talking of fab. The time is right now. We should just do it. I don't know what else to say. And I can tell you that Applied Materials, we are not waiting. We are proceeding.
I mean, just from Lam's perspective, again, we are here in India to stay. We've made enormous commitments, just like Applied, our friends at Applied have done, to India to in terms of building infrastructure, building capability. So some of the kinds of capability building that's gone on for the last 20 years is a phenomenal foundation on which the country can build a semiconductor industry. We've actually brought a lot of people into the domain, into semiconductor industry over the last 20, 25 years of our existence here. And then, of course, Professor Vasu and the educational institutions have also contributed their part. So if I look forward, I think the main question is, do we have the will to invest? And as Vikas said, do we have the patience to stick with it? Do we have the commitment? Because God knows the customers exist here in India. And I think the imperative, the strategic imperative exists. The rest of the world is actually looking for alternative places in which some of these supply chain constraints can be removed. And so that opportunity also exists. It just all needs to be brought together. And I think with some visionary government at the helm, we should be able to bring all these elements together and build a semiconductor industry on what's already been established. I'll just give you a simple fact. Like today, you talk about services, something that we have not discussed at all. Today, Lam uses Indian talent to not only install, but maintain its equipment in our global customer base. And we find that this is world-class talent, able to do stuff that anyone else in the world can do. And so that foundation exists. We just need to have the will to go build on top of it.
Professor Vasu, any comments?
Yeah, the way I look at it is you can't stop an idea whose time has come. And, like Srini said, the consumers are here. And unlike in the petroleum industry, where it depends on where crude oil is found, that is not a stumbling block in the case of electronics. It's all an IP which can be generated here. And I think if not a silicon fab, we are setting up the photovoltaic industry. So if the entire supply chain for that can be set up, including making of the silicon in India, that could be one beginning and a good stepping stone to maybe a IMEC-like fab and eventually a larger fab. And then wrap it up with fabs in other areas like silicon carbide and gallium nitride, which are coming up, which may not need as much investment and in which you can compete more effectively than you can in the case of silicon.
Thanks, Professor. I think that's what, as IESA, we have been recommending to the government in various forums, that we should look at these specialty fabs, and that's where we may not have that kind of a gap compared to the rest of the world. I think with that, we have come to the end of the session. We will probably take a short break and then wait for the Q&A from the audience. So unless anybody has, I think what I just wanted to tell everybody that we actually will need to basically organize a supply chain summits. I think this whole thing will end up in having a supply chain summit maybe 6 to 8 months down the road, and we will work very closely with Invest India and Ministry of Electronics and Information Technology and associated industry to take it to the next steps. And I'm really happy that both Applied as well as Lam want to put their best foot forward to help the country and to help India to take next steps in the global supply chain semiconductor manufacturing. Thank you, everybody. And then we will basically listen and request for the questions, and probably you be here so that we can listen to the questions from the audience and maybe from the panelists as well. Thank you.
Thank you.
We have a couple of questions which have come up. Am I audible? Yeah. See, I have a couple of questions. I think 3 or 4 of them. I don't know whether we have time to basically complete all of them. One, I think I'll pick up in terms of priority. I'm trying to prioritize them. So the first question which has come up is, Intel and TI inspire design startups in India. Do you see AMAT and Lam doing the same in equipment domain as well?
Could you please repeat? You're saying that would Lam apply incentivize startups in India?
So what I could understand is, see, because of Intel and Intels of this world and TIs and Qualcomms of this world, setting up the huge development center here, that also fueled local design startups in the chip domain. Do you see Applied and Lam doing a similar thing in the equipments domain?
Right. So we don't kind of set out to create startups. What we do is we create an ecosystem within which people can fill gaps. So LAM, for example, is going to be investing fairly significant amount of money to set up a center of engineering here in Bangalore. We are setting up a very sophisticated lab. We're bringing in capability that probably hasn't existed before in India in terms of the equipment, the types of problems that we're going to solve, the kinds of people we're going to hire to solve these problems. And in that process, we create people with good ideas, good technology can fill gaps. That's how I think it works. And that's what we're setting out to do. I'm not sure if that answered the question that's being asked, but that's our intent. And I think, you probably will read it in the press, but pretty soon we will be having announcements about capability center being built here in Bangalore.
Can I ask the other panelists to turn on their video, please? It seems to have gone off for some reason. Thank you.
Thanks, Sharda. Sri, one more question. I think yesterday, I don't know whether you heard about from the government. They made an announcement that that there will be a fab coming in. It came from the Ministry of Electronics and Information Technology. So we may see a fab coming in soon. At least the announcement coming in soon. And also ATMP is coming. I think that announcement has already come. There are a couple of companies who have already shown interest and started the work in that area. Do you see, what recommendations do you have for the government and the industry so that they can start actually producing those chemicals and materials and start supplying not only globally or as well as getting prepared for the local industry as well?
Well, I would say the government should create an ecosystem and the logistics networks necessary for this to flourish. I mean, so for example, bringing up a fab in India and then accelerating the cycles of learning and innovation is a very important announcement. I think that's very laudable, and we're very happy to play whatever little role we can as an equipment supplier in making that dream come true. Once that's set up, and once we do actually have an internal customer within India for chemicals and materials and other, then I think I see that industry flourishing. Let me give you kind of an example from another industry. Back about, and I'm probably one of the oldest people on this panel, so I remember this actually. Back in the 1970s, you probably remember that we actually had two small manufacturers of automobiles. And then the government basically incentivized and set up Maruti Udyog Limited and brought in technology, build cars and make cars. And with that move, with the with the collaboration with Suzuki, came the entire supply chain for the automotive industry. So I see that that is a good model, to be honest with you. As you incubate this kind of production capacity here, it's very likely the associated supply chain will also come along for the ride. So to the point that I think Professor Vasu made earlier in the conversation, we should look for ways to incentivize current suppliers in this space to create capacity here. Because as I think was mentioned, there are 27 or 28 now new fabs coming out of the world. They're going to have their own supply chain constraints, and adding capacity in India while accelerating cycles of learning through an internal customer is a fantastic opportunity. And I'll defer to the rest of the panel to fill in any other details.
Professor Vasu, you want to comment, or Sagar, please, before we move to the last question?
No, I think I completely agree with what Srini has said. Maruti is actually a fantastic example. And world over, we have seen that, you don't get into whether the chicken came first or the egg came first. You enable one of them, And in many ecosystems, a fab is brought in, and then the ecosystem is built around it very often. All right, so I think we should just go ahead.
Thank you. Should we move to the last question? I presume Sagar does not have any comment. Maybe for the last one he has. So I think the one more question which has come. In fact, there are many more, but then I think respecting the time, because we have another panel getting started after this. So many chemical engineers and metallurgy engineers from the top engineering colleges do their engineering, I mean their engineering BTechs here, and then immediately shift from their traditional chemical engineering to the software. Do you see that as a that will hamper the growth of these industries? Which I mean to say is basically, do you see a problem? Do you see a concern there? You may not be able to getting the right talent or the best talent in chemical engineering and metallurgy engineering or metallurgy engineering.
I'm guessing that's a question for me. I don't see why not. I think there are all kinds of students out there. For them, for some, salary might be the only motivation, and it's fair to say that the industry has to be competitive on the salary front. But there is still a chunk of people out there who feel that it's not just salary, and they would.
I think we lost Mr. Vasu. Dr. Vasu.
While Professor Vasu, oh, there he is.
Yeah, sorry,
We lost you.
did you lose me? I see. Okay. No, I was saying that from a supply chain perspective, you will never have a constraint as far as HR in India is concerned. We produce enough people to supply to both the software industry and to many fabs. And it's not just salary alone always. Occasionally it is. The system will have to then be competitive. But many people also take up a job for the challenge it offers, given their background and training.
Thank you. I think
on a lighter note, if the setting up of a fab allows people to climb and apply tools to rescue chemists and chemical engineers from the drudgery of software writing, we'd be very happy to contribute.
Good one. Thanks, Krishna. Thanks, Rini. Thanks, Professor Vasu. Thanks, Sagar. Thank you very much. I think we can close the panel. Thank you very much, everybody. Look forward to see you for the next follow-up panel, which will be probably in a couple of weeks. I think I will invite you again for the iesa panel, which we'll be doing for the BTS. Thank you very much. Over to you, Sharda.
Thank you, Rajiv. Thank you.
Thank you, Rajiv, and your amazing panelists. It was an extremely interesting discussion. Clearly manufacturing and R&D are tightly integrated. We have seen over the last 35 years the growth of IP development and design services in India. And it looks like it's time for the supply chain of manufacturing, to wake up and become a roaring lion, so to speak, right? We talk a lot about manufacturing, but before that, much can be done in terms of the supply chain, and then we get to manufacturing as well. And I think we had a good panel with a combination of industry, investments, research, and so on and so forth. So replicating what we did with IP and services space.